Hello viewers, in today's class we are going to discuss one important problem from limits, right? And here we have to evaluate this limit where we have a limit x tends to 1 minus this negative sign shows that we have to find the left hand limit of this function when x approaches to 1 from the left of x is equal to 1, right? So we have to find limit x tends to 1 minus 2 times signum of x plus 3 and divided by the mod of 1 minus x. This is the absolute value function plus the square of the greatest integer function x plus 1, right? So in this limit we have three important functions. The first one is signum function, the second one is the absolute value function, which is also known as the modulus function, and the greatest integer function, right? So let us start, right? So here see we have x is equal to 1, right? And we have to approach towards x is equal to 1 from the left of x is equal to 1, right? So we'll take a point in the neighborhood of x is equal to 1, which lies towards the left of x is equal to 1 but very close to x is equal to 1, right? So here we'll take x is equal to 1 minus h, right? So this point is 1 minus h, right, where h is a positive quantity and h is greater than 0, right? Okay, so now here we'll take x is equal to 1 minus h, and when x tends to 1 then obviously h tends to 0, right? Okay, so now this limit can be written in terms of h as a limit, and we'll write h tends to 0, and here we have 2 times signum of x plus 3. So x is 1 minus h, so we have 1 minus h plus 3 divided by mod of 1 minus x. For x we have 1 minus h, so we have minus 1 plus h, and then we have the greatest integer of 1 minus h plus 1 square, right? So let us simplify this expression. So we have limit h tends to 0, and we have 2 times signum of here we have 4 minus h, and this is 3 plus 1 4, 4 minus h. Then we have here 1 and 1 get cancelled, so we are left with mod of h, and here we have 1 plus 1 2, so we have the square of the greatest integer of 2 minus h, right? So now we have to evaluate this limit, right? And see here we cannot take directly h is equal to 0, right? So here we have the signum function, the mod function, and the greatest integer function, right? So first we'll take the signum function, right? Now see, if we define signum function, then signum of x can be defined as plus 1 whenever x is greater than 0, and signum of x is equal to 0 whenever x is equal to 0, and signum of x is minus 1 whenever x is less than 0, right? Now let us concentrate on this term, that is 4 minus h, right? And here we know that h is a positive quantity, but it is a very small quantity, right? So h is infinitesimally very small. So when we subtract h from 4, then 4 minus h is obviously greater than 0, right? Because 4 minus h is a positive quantity, right? And whenever x is a positive quantity, that is x is greater than 0, then signum of x takes the value plus 1, right? So signum of 4 minus h is always equal to plus 1, because this quantity 4 minus h is greater than 0, right? So here will have plus 1, right? Okay, now let us take the greatest integer of 2 minus h, right? Now see, 2 minus h is greater than 1, right? But it is slightly less than 2, because h is a positive quantity, right? And when we subtract h from 2, then 2 minus h is greater than 1, but it is less than 2, right? So from the definition of greatest integer function, we can now write greatest integer of 2 minus h as 1, right? So here we'll take 1, right? So now this limit reduces to a limit h tends to 0. We have 2 times plus 1, because signum of 4 minus h is plus 1, and here we have mod of h, and here we have 1 square, right? And now this is 2 times 1 is 2, and mod of h tends to 0 when h tends to 0. So here we have mod of 0, and here we have 1 square is equal to 1, right? So now here we have 2 over 0 plus 1. So this is 2 over 1, that is equal to 2, right? So this limit is equal to 2, right? Or in other words, we can say that the left hand limit of this function when x approaches to 1 from the left of x is equal to 1 is equal to 2, right? So viewers, this is how we can find out the limit of this function.